Hello everyone and welcome back to InSciLabTech community. I am Dr. Anjana Verma, a research consultant at InSciLabTech. As part of our For Researchers by Researchers initiative, I am here to show you how to perform XPS analysis using OriginPro. I have divided XPS analysis into three parts for clarity and accuracy. In the first part of the video, we have performed the carbon correction and calibrated the survey spectrum. The link for the part 1 of the video is in the video description. Now we will use carbon correction to process the high resolution titanium 2P peak of my TiO2 sample. Let's open your Origin project where you have saved all the data. You can check the part 1 of the video for up to this point. Now my data is titanium on which I want to perform the analysis. So enlarge this data. So we'll add 2 new columns. So select this, add 2 new columns. I'll copy my original data in this new column. By doing this, when I'm doing the energy calibration, my original data is not affected. Copy the sample description also here. Now my C column is binding energy, which is x-axis. Select the column and set as x. Now binding energy offset of 1.6 electron volt has been observed. We have seen in part 1 of the video. So my column C has to be modified with 1.6 electron volt. So in the formula box, type C1 plus 6. Hit enter, your binding energy will be modified. Now we will plot. Select the columns, plot the line graph. Now we want to do the fitting. Go to analysis, pick some baseline, pick analyzer, open dialog box. Goal is to fit the peak, select it. Go to the next, baseline mode, select XPS. Next. Now when I selected the Shirley method, the auto-generated baseline is not a realistic one. So let me check for the Tougaard method. In Tougaard also my baseline is not passing through this center point. That means it is also not a realistic. So what should we do in this case? In Origin we have another option for such type of data that is called as user-defined baseline. So if your data is if your baseline, the auto-generated baseline is not realistic, then you can use the user-defined to create a realistic and smooth background using the user-defined Spline method. And if your background is curved and broad and data is very noisy, then you can use the Spline to create a smooth baseline curve. So in my TiO2 sample, titanium 2P peak when baseline is created using Shirley, it is not realistic. Even Tougaard method, the auto-generated baseline is not correct. So I have used the user-defined baseline, which passes through all the low energy tails to give a realistic baseline. Sorry. So let's see how to do this. Go to your origin file. Let's go back. Goal is again fit the peak. In the next, instead of XPS, select the user-defined. When you select the user-defined, some anchor points are created on the spectra. These are positioned at the place where non-absorbing regions or where peaks are not present. So, if you want to change the position of the anchor points, or if you want to add more anchor points, then uncheck the enable auto find. And if you want to add, click add, or you can increase the number or decrease the number from here. If you want to modify, click modify. For example, I want more anchor points on this side, so I'll move one over there and realign the position. So just select the anchor points and drag to a new location where you want. Once all the anchor points seems to be okay, click on done. then click on next. Now interpolation method, for XPS we select either Spline or Spline to create a smooth curve baseline. In Spline it is passing through the all data point, or you can select the BSP line. For my data, Spline seems to be okay, so click next. We don't have to do anything over here, so just click next and next and finally finish. So your fitted spectra with peak appears on the screen. You can check the exact peak value from the table. Now we want to plot this data for using in the paper. So this is my titanium data. The fitted peak information appears as a new sheet. Fitted peak curve values appears again as a new sheet. Peak properties like FW, HF, area, peak center appears in the new sheet, and my baseline data appears in another sheet. Now I want to plot a publication ready plot. So select your calibrated energy and intensity column, go to plot, scatter plot. Now at the left corner there is one written. So this is a layer, number of layers in the spectra. Double click on it, a layer content will be opened. It has showing all the data present in your origin book. Now we'll arrange as per the book name. Now my data is in the titanium book, so titanium CSV where my data is present. So intensity already original data. Now I want to add the data for the peak 1, fitted peak 1. Select the data, click on this arrow to add to the layer. Do the same for the peak 2, select, add to the layer. Cumulative peak, select, add to the layer, and we want to add the baseline data as well. Select and add to the layer. So now we have added 4 data corresponding to the peak 1, peak 2, cumulative data and baseline data added to our original layer. Click OK. All layer has been added, but they are overlapping and we cannot distinguish anything from it. So double click on the spectra. A plot detail properties window will open. So my first data, the scatter, I want it to be circular instead of a rectangle. Fit peak, I want plot type as a line. Make width as 5 and change color to red. For fit peak 2, select the plot type as line. Width 5, color blue. For cumulative peak, again plot type as line. Width will be slightly smaller and left color will be the green. Keep some transparency. This will help to identify the peak 1 or peak 2 if they are perfectly overlapping with my cumulative peak. For baseline, again I will have the line. Width keep 5 only, color gray. Apply, OK. So now your data is ready, but in XPS energies are presented from high to low values. So double click on the x-axis, go to the scale tab and type your higher energy value and lower energy value in the to field and apply. So your energy values are now presented from high to low values. For presentation purpose, I'll add the top and right side lines. So go to the lines and text, select the top, show lines and text. I don't want any major and minor text, so select none for them, apply. Do the same for the right side, show lines and text, select none and apply. Now this information is not required for paper, so we'll remove it, and intensity values also will be removed. Now text box select and add the information about your spectra, that is titanium 2P. Also we want to label the 2 peaks present. So select the toolbox, click on the file, write down the peak information. This is 2P, 1 by 2P, 1 by 2, 1 by 2 is suffix, so select and make it suffix. So all this formatting I want to copy, so select this text box and paste it for the second peak. So I don't have to type everything, just rename as 2P, 3 by 2P. So once all data is been labeled, we want to export this image for using in the paper. So go to File, Export Graphs, open dialog box. Select the file type as PNG, file name as per your sample. Select the file location where you want to save the data and make sure that your DPI resolution is 300 or more. Apply. OK and close. So your titanium 2P PNG file has been created. You can open and check doc. So this is the titanium 2P high resolution XPS image which you can use in your thesis, research paper and presentation. I hope the second part of XPS series was helpful for your research. Join me in the third part of the series where we will show how to deconvolute the high resolution XPS peak. To continue the conversation, ask questions or collaborate with fellow scientists, please join our community hub at InSciLabTech. The link is in the video description. We would also love to hear your feedback directly. Let us know what you think in the comments. Thanks for watching.